Hello code lovers and welcome to Code Framer. So in this video we will be solving one more problem related to recursion, which is to calculate power of a number using recursion. So if you are new to this channel and you are watching this video for the first time, then I highly recommend you to see the last 4 videos that I have taken, where I have clearly explained what is recursion and how basically recursion works in the background and what are the different steps that we can use to write a recursive function. So basically how you need to think while finding a solution using recursion to any problem. So those concepts are explained in the last few videos, so you can go back to those videos, get complete understanding of that concept, and then come back to this video to solve this particular problem. So here are those videos. So you can first watch Understanding Recursion, which is video 6 of this particular data structure and algorithm tutorial, and then you can have a look at writing recursive function part 1. So there is a part 2 as well for this particular video. So after getting all those understanding, then you can come to this video and solve this particular problem. So I have given the links of all those videos in the description, so you can go and use those links to see those videos. So let us move forward. So let us go back to the problem that we are going to solve in this particular video, which is to find power of a number using recursion. It's a very simple problem, but yes, it will definitely help us to understand recursion in a better way. So that is the main purpose of this particular video, because as you could see that solving a power of a number should be a very simple problem to solve, and there are many ways to solve it if you think about it. You can use a for loop to solve this problem, you can use a while loop, and there are other ways as well. But how to solve it using recursion is something which will help us to understand recursion in a better way. So let us start. So first of all, what is power of any number? So for example, if we write 2 to the power 4, it simply means that we multiply 2 4 times, so which is 2 multiplied by 2 multiplied by 2 multiplied by 2, and it will give us the result as 16. So now the question will be that how we can basically get this result for this particular expression using recursion. Now remember one thing, that whenever we write 2 to the power 4, then here 2 represents the base and 4 represents the exponent, right? So 2 is the base and 4 is the exponent. So here the problem statement is, how can we write a function which accepts a base and an exponent and which could return us a result, which means it can return us power of that number. So this is the problem statement, and we need to write a recursive function in order to achieve this result. So I recommend you to pause the video at this point and think about the solution yourself, and once you come up with the solution, then maybe you can continue and watch the solution in this video. That will be a good practice because it will help you to understand recursion in a better way. So you can pause the video right now and give it some thought, and then you can see the solution to this problem in this video. Okay, so I hope that you would have given it some thought. Now let us have a look at the solution. So in order to find solution to any problem using recursion, we need to follow the steps, right? The steps to write a recursive function. So what is the first step? It is to find the recursive case. So whenever we are trying to find a solution to a problem using recursion, the first step that we need to think about is to find the recursive case. Is there anything which is repeating in this particular problem, right? If something is repeating in a pattern, then we can take that as a recursive case, and from there we can write our recursive function. So in this problem where we saw that 2 to the power 4 is 16, how we can find a recursive case? So basically when you write 2 to the power 4, you can represent this as 2 multiplied by 2 to the power 3, right? So 2 to the power 4 can be represented as 2 multiplied by 2 to the power 3. So both are basically the same thing. Now 2 to the power 3 can be represented as 2 multiplied by 2 to the power 2. And now if you want to break 2 to the power 2 further, then it can be represented as 2 multiplied by 2 to the power 1. And as you know that 2 to the power 1 is nothing but 2 itself, which means that whenever our exponent becomes 1, then you can basically return the base number itself. So now having understood this, you could clearly see that there is a recursive pattern in this particular problem. So we can use a recursive solution to this problem. And the recursive case to this problem can be represented as any number x to the power n can be expressed as x multiplied by x to the power n minus 1. Right? Because 2 to the power 4 is equal to 2 multiplied by 2 to the power 3, which means that any number x which is having a power of n should be equal to x multiplied by x to the power n minus 1. So this particular expression we can use to create our recursive case. So now since we have found our recursive case, now let us move on to find our base case. And I'm sure that by now you would have guessed the base case. It is nothing but whenever our exponent becomes 1, from that point we don't need the recursion anymore. So now when we are trying to find the base case, we can say that whenever the exponent is 1, we can return the base number itself. And whenever the exponent is 0, we can return 1 itself. Now just to give an example to this, if we write 2 to the power 1, it basically means 2, or any number to the power 1 is equals to that number, right? And if we write 2 to the power 0, then it will be always equal to 1, which means that any number to the power of 0 is always 1. So finally we can say that whenever exponent is 1, we can simply return the base, and this will be our base case. So now, having found our recursive case and the base case, now we can go to the editor and write our recursive function. So always remember, when it comes to solving problem related to recursion, you always need to first clearly define what will be your recursive case and what will be your base case. So do not start coding before finalizing the recursive case and the base case for recursion, because if you start coding and if you try to find solution while coding, in some of the problems it will get really confusing. So before starting to code, always remember to first work on finding the recursive case and the base case. Once you have found the solution, clear solution, then you start coding. That is the best practice to write any recursive function, or basically while coding in general. Always finalize the solution first and then start coding. That is extremely important. Okay, so we are in the PyCharm editor. So now let us start writing our function. So first we need to write a function. So let us say power is the name of our function, and we will accept two arguments, which is base and the exponent. So let us name it just exp. That should be enough. So this function will accept base and the exponent. Now let us first write our recursive case. So what was our recursive case? If x is the base number and n is the exponent, then we can write x to the power n will be equal to x multiplied by x to the power n minus 1. So this was our recursive case, if you remember. So we can write return base multiplied by, and now we can call the function recursively. So we can write power, and then inside the bracket we have to pass two arguments. So the base will remain the same. We will subtract the exponent by 1, which means exp minus 1 will be our new exponent for the recursive call. So this will be our expression for recursive case. So since now we have written our recursive case, now it is time to write our base case. So if you remember, we had two base cases, right? If the exponent value becomes 0, then we will return 1. And if the exponent value becomes 1, then we will return base itself. So we can write if exp is 0, then we can return 1. And if exp is 1, then we can return base. So this will be our base case. So now let us first execute this recursive function and see whether it is working or not. So we can write print, and then we can call the function power, and inside it we can use the same example that we saw earlier, which was base 2 and the exponent was 4. So now if we execute this function, then as you can see that we are getting the result as 16, which is correct. So let us give one more example. Well, let us say 3 as the base and 3 as the exponent. Answer is 27, which is correct, because 3 multiplied by 3 is 9 and 9 multiplied by 3 is 27. So it seems that our function is working perfectly fine. So I hope that you are able to understand how we can basically write a recursive function to any problem. So the first thing is always to decide what is our recursive case, and then we can decide what is our base case, and then only we need to start coding the solution. Now finally, we also have to think about step 3, which is to find the edge cases. So if you remember, even in the last video, while solving the GCD problem, which is greatest common divisor problem, we wrote our edge cases, and which basically made our recursive function much more stable, because it could accept wrong user inputs and it could respond with appropriate error message. Instead of throwing an exception, we could simply give an error to the user for wrong inputs. Similarly, we need to handle such unexpected or unintended inputs to this function, which could probably break this function as well. So just pause the video here and think about those various inputs that could probably break this particular function. Okay, so I hope that you would have given it some thought. So the only edge cases that I could think about is that the exponent cannot be a negative integer, right? We cannot find power of any number where the exponent is a negative number. So that is one of the edge cases that we can handle. And also, of course, one more edge case is that the exponent cannot be a non-integer number. So exponent always has to be a number. And the same edge cases is applicable for base as well. So base also has to be an integer, and also it cannot be a negative number. So in order to handle these edge cases, we can write some conditional statements. So first we will write if integer of exp is not equal to exp, then we can simply return invalid input. So whenever the exponent is not an integer, then this particular condition will be true, and user will immediately get a message that the input is invalid. So by writing this conditional statement, we have ensured that exponent always has to be an integer. Same condition you can write for base case as well, but I'll just continue to give the example of handling the edge cases for exponent alone, but you can definitely use the same conditional statements for base number as well. So another edge case that we had is exponent cannot be a negative integer. So we can write a very simple conditional statement that if exp is less than 0, then we can simply return exponent is negative number. So this will be the error message that the user will get if the exponent passed is a negative integer. So by writing these two conditional statements, we have handled the edge cases or any unintentional wrong inputs to this function which could probably break this function. So now I think this particular recursive function looks much more stable. So as I said earlier that you could use the same conditional statements for base as well. So this was just to give you an example that how we can basically handle different edge cases for any recursive function. So if we execute this function now, then as you can see that we are getting the same result. And if we pass, say for example, a negative exponent number to this function, then as you can see that we are getting an error clearly that exponent is negative number, which means that the user is getting an error response here for passing a wrong input. So this is how we can write a recursive function to find power of any number. And I hope that this concept was clear. So now let me quickly explain how this recursive function is working in the background. So let us give an example of 2 to the power 3 where 2 is the base number and 3 is the exponent number. So when this function is called, then the base becomes 2 in the function and exponent becomes 3. So these two base cases will first fail because exponent value is 3 right now. It is neither 0 nor 1. So the recursive case will get executed. So in the recursive case, the value of the base will be 2, which will be multiplied by calling the recursive function where base will be 2 and exponent value will become 2 this time. So again, the recursive call will be made to the same function, and this time the value of base will be 2 and exponent value will also be 2. So again the base conditions will not get satisfied, so the recursive case will get executed where base value will be 2, which will be multiplied by the function call where the value of base will be 2 and the exponent value will become 1 this time, right? Because 2 minus 1 is 1. So again the recursive call will be made, and this time again the base value will remain as 2, but the exponent value will become 1. This time the base condition will become true, because if the exponent value is 1, then base number will be returned. So which means since the exponent is 1, 2 will be returned for this recursive call. So now when 2 is returned to the earlier recursive call, then 2 will be multiplied by 2, right? Because in the earlier recursive call, base remained as 2. So which means that 2 will be returned here, and 2 multiplied by 2 will be 4. And this result of 4 will be returned back to the earlier recursive call, where again 4 will be multiplied by 2, and finally we will get the answer as 8. So this is how this particular recursive function is working in the background. So I want you to pause the video for some time and go through this solution multiple times so that it becomes absolutely clear to you that how this recursive function is working in the background. That is something which is extremely important for you to understand. Take it slow and try to understand this recursive function well. So I hope that now it is clear to you how we can solve the problem of finding the power of a number using recursion, and it really helped you to understand recursion better. So in the next video I'll come up with another problem which we will solve using recursion, and after that I'll give you a lot of practice problems which you can solve yourself. I can show you as many examples as possible, but at the end of the day you need to practice recursion yourself by solving more and more problems from different platforms like LeetCode or Geeks for Geeks or HackerRank and other platforms like Codeforces. So there are many platforms from where you can basically solve problems related to recursion. The more and more problem you solve related to recursion, the more and more comfortable you will get to find solutions related to recursion. So having said that, thank you for watching this video. If you like this video, then hit that like button, share it with other code lovers, and subscribe to CodeFramer for more videos. See you next time.